Hello guys, this is Saharsh and today we are going to study about Hadoop, why it's required, how it works and all the ifs and buts we're going to discuss today. So let's get started then. Nowadays we are hearing this term a lot called as big data and its problems and all. Large chunks of data is called as big data. It can be in gigabytes, petabytes and even more. Now, this big data is generated from various social platforms like FB, Yahoo, Google+, Twitter. Whenever we log in, we create logs, our photos, our posts, everything. All these account to big data. Banks, they have transaction logs, backup data, all kinds of account details of every person who is a member. All these things collectively constitute to big data. Even the surveys which are conducted online, offline, all kinds of analysis of different parameters, customer feedbacks, along with security logs, all these form big data. It is stored in data centers. These data centers are rooms equipped with heavy hardware, which have high RAM, super high processing, and storage capabilities. As we can see that FB has 400 TB of static user information only and is growing at a rate of 24 TB per day. That means FB has to buy a new server every week, and that constitutes to 52 high-end servers. That's a good hole in pocket. Now, we are humans and we need highest output with lowest input. And the idea is to move computations or the data processing towards the storage. Of course, why would I like to download a 5 gigs of file, then edit it? I just want to send commands to the servers which have super high processing power and let them process that file for me. Now our legacy is that we have application, data processing, metadata management on our side and storage on the network side. Now what we have done is we are transferring metadata, that is index of the data, towards the network side. But we like to live in future. Now what the recent tech developing is we even transfer the data processing onto the network side so as to minimize the time. Let's take an example. Well, I'm hungry and I sure want to have a pizza. So talking about earlier times, we have to go to the grocery store, that is storage, with the list of ingredients, that is metadata, and find all the ingredients. And we have to cook the pizza ourselves too, that is process it if it was tiresome. Now what we did, we told the owner to keep ready all the ingredients. We just have to go and pick them, cook pizza and eat it. Still that cooking, that data processing is taking too much time. Now what we can do is we just place a call to the owner that I want to have a pizza. Our favorite pizza will be delivered at home in no time. Which method is fastest? Yeah, the last one. Similarly, sending few kilobytes of info towards the data center is far too easy than downloading a 5 gigs file. This is how we achieve faster processing of big data. Now let's come to Hadoop. Bob Cutting, the lord of Hadoop, was reading a Google research paper on Google file system and Google MapReduce. He was quite inspired and developed Hadoop. One interesting thing is the name Hadoop, how it's named. Bog's son had a toy elephant who he named Hadoop, and so good father kept the name of his new tech as Hadoop. So what's Hadoop? It's an open source framework. That means public contributors are developing it, and it's comprised of algorithms, subprograms which are used for distributed storage. It means it works on multiple storage hardware simultaneously. And distributed processing, that is processing the distributed storage all at the same time. It works on large data sets, that is big data. On a computer cluster, that is several computers connected to form a group or a community hardware. In a broader way, it has two functions, massive storage and faster processing. Now Hadoop, it has four modules, namely Hadoop Common, Hadoop Distributed File Storage, HDFS, MapReduce, and Yarn, yet another resource negotiator. Let's dive in. Hadoop Common contains all kinds of libraries, utilities, on all the algorithms and codes of Hadoop. HDFS, it acts as an aggregated storage system which makes computer act like a cluster. All the computers in a group or a LAN will act like a cluster, act like one storage. Now MapReduce, it is a programming model which is used for processing of big data. Yarn was included in Hadoop 2.x and it is a resource management platform, and it provides support for the non-MapReduce applications like Giraffe, Pig, Spark, etc. Now let's see an example of working of these four modules. I've never been to Goa and I really want to go. So I have to book the air tickets. I will go to Air India website. Now the Air India's website contain all kinds of protocols, rules, direction to be followed, how tickets are booked, how to check in, all kind of things, all kind of rules and protocols. Then the website's storage server. where all the details are stored distributively according to the country, flight type, number of seats available, and even the personal details of all the users. And this data is used simultaneously. It acts like a distributed file storage. Then it comes airplane allocation. Although we always get desired seats when available, but the allocation of aircraft is dependent on empty seats, recent flying of that particular aircraft, and all this data of users and aircraft has to be mapped and optimized solution has to be found of which aircraft to allot to which passenger or to the which group of passengers. And travel agents. Of course, when I have to buy a long ticket or some kind of complex tickets, I would go to travel agents. These travel agents allow us less pain while booking tickets. Even some kind of privileges are allowed to these travel agents. Already booked seats are available for some travel agents. So these travel agents give us an extra wealthy possibility of booking tickets. Now let's compare this to Hadoop system. Similarly, Hadoop common package. It provides all kind of file system, OS level files, documentation, support codes, source codes. Since it is an open source software, always supplies source code. The website storage server will be converted to Hadoop distributed file system. It will span over all the nodes in the cluster. That means if there are 5 computers, 10 computers, this HDFS will constitute of all those 5 computers storage. And it will link them all together so as to act like single storage. It provides high aggregate bandwidth. Now, airplane allocation system can be analogous to MapReduce engine. MapReduce engine has job tracker and task tracker services. Now, what these services actually do is the client submits the application or the query, and these services solve that query. You can dive deeper into MapReduce by watching another video by Ishan Sharma, which focuses on working of MapReduce. These travel agents, they were added later in tourism sector. Similarly, Yarn was added in Hadoop 2.x. It is yet another resource negotiator. It is a resource management platform which assigns CPU, storage, and even the memory to non-MapReduce applications. Now, if we have third-party applications or then applications other than only MapReduce, we have wealthy possibilities. We can do all kinds of analysis, every kind of computation, complex, simple. We have a whole door open ahead of us. Once again, the reservation website, the rules, they are held in Hadoop common package. The storage server or the storage HDD, that will be HDFS, by distributed storage. The airplane allocation or that all kind of optimization work that is being done, it will be done by Hadoop MapReduce engine. And these travel agents or the third party applications or the extra privileges will be given by Yarn. This Yarn also contains a MapReduce engine. Since it is in Hadoop 2.x, it already has MapReduce engine along with application masters, containers, resource managers. We will talk about these in later slides. Now the architecture. Hadoop is designed as a master-slave architecture or the shared nothing architecture. It's as same as a dual SIM phone. What happens is these two SIM have their own network, individual memory space, individual slots. They just share a common mobile hardware. Similarly, Hadoop's master nodes and slave nodes share only that Hadoop architecture. The master nodes, as in Hadoop 1.x, there was only single master node, that is, it contains job tracker. It keeps a tracks of jobs, all kinds of jobs, queries that will be coming to the Hadoop will be handled by job tracker. Name node is at HDFS layer. This name node contains all kinds of metadata. It has all the information about where all the data is stored, where are the copies and everything. Slave nodes contain task tracker. This task tracker manages tasks and it is individual to every node. It schedules and reschedules tasks in case of failures and makes sure that every task is performed. Now on the HDFS layer, there is data node. Data node contains all kinds of data, even the copies of data, and all the blocks are held here. Now let's see how it is physically placed. We have an admin node, which has all the privileges, full control of everything. It is connected to the network switches. These network switches route the command of the respective cluster for where it belongs. In this, we have two edge nodes. These edge nodes have the direct interaction with all the queries, all the jobs. These control nodes, they drive the particular connections of the respective data nodes, which contain the information. And the data nodes, they can range from minimum 3 to n number of data nodes. These all contain the copies and all the data. Rec awareness is a feature which works perfectly when data nodes are 3 or more. Now, why should we use Hadoop? Hadoop provides us various kinds of features and extra privileges. It's scalable. It means that new nodes can be added and can be removed without modifying any kind of data, without handling any kind of processes. It's cost effective. That means it brings parallel computing to commodity servers. Now, commodity servers are not cheap PCs, they are cheaper hardware. I don't have to go and buy a supercomputer. I can work with quite lower configuration also. These are commodity servers. Now, since it works on a cluster, that means the jobs which used to take 20 minutes of time now will take 2 minutes of time on a 10 computer cluster. It's flexible. That means it is schema-less. I can give in PDF. I can give in any type of data that is structured, non-structured or semi-structured. Structured data comprises of enterprise data, which is well defined. Semi-structured data consists of tables. And unstructured data comprises of all kinds of raw text files, PDF files. It is fault tolerant. That means data and application are protected against all kinds of hardware and software failures also. Now the interesting feature is self-healing. Now before moving on to self-healing, there's two terms, replication and rec awareness. Hadoop replicates every data 3 times. And rec awareness means that Hadoop recognizes when there are 3 or more than 3 nodes. Let's take an example. If there is a big file, it is distributed into 3 chunks, A, B and C. Hadoop will store 2 blocks on the same rack but on different nodes and 1 copy on another rack. So in case if there is a system failure, there comes a query for block C and somehow node 2 of rack 1 is failed or damaged, then it will start searching on the third number of node on the rack 1 only. But now there comes a bigger failure on the system or lights go down, it will start searching on the rack 3, and by the time it figures out that there is a problem that is occurred, it will start copying all the data of rack 1 which is damaged onto another rack. So there is no probability of losing your data. Moreover, there is no kind of hindrance in processing. Still continue to fetch and give your computations toward the storage. This is self-healing. Security. Although Hadoop was developed without security in beginning, but now it is equipped with Kerberos security. That means the machines have to have mutual authentication before communicating with each other. It also uses pluggable authentication. It is a mechanism to integrate multiple low-level authentication schemes into a high-level application programming interface. It allows programs that rely on authentication to be written independently of the underlying authentication schemes. Of course, file permissions, that is, administrators have all the permissions and the users can have restricted permissions. Network encryption is there, so it's quite secure. Then some kind of extra features is index building, text mining, graph creation and analysis, prediction models, in which we can know about what kind of data will be coming in future years, pattern recognition, risk assessments, etc. Now let's compare the conventional storing system, that is RDBMS, and Hadoop, the new technology system. RDBMS stands for Relational Database Management System. Of course, it's based on relations. That means it can only have structured data. While Hadoop, as told, it's schema-less, so it can store all kind of structured, semi-structured, and even unstructured data. So you don't have to worry about what kind of data you're putting in. RDBMS is based on limited scaling. It means if I ever run out of memory, then I'll have to buy another server and I have to copy all the data, relation, tables, all kinds of softwares needed for it onto the another machine also. It means it will handle the process and the transactions. While Hadoop is based on a scale out structure. Whenever you run out of memory, just go to the store, buy another server, add LAN wires, and you're good to go. RDBMS is of course an expensive expansion, as I have to buy that high-end server which can handle these transactions, and these servers can almost accommodate 1,000 transactions at a time. While Hadoop works on commodity hardware, that is cheaper hardware, and in a cluster it can work upon up to millions of transactions per second. Here RDBMS, all kinds of failure has to be handled by the programmer. The programmer has to write the instructions such as logs, transaction logs, checkpoints. While in Hadoop, the failure is handled by application layer. The task tracker and the job tracker reschedule any kind of incomplete tasks. While the cost is an important factor, RDBMS can cost us up to $100 to $100,000 per TB. Of course, it needs a high-end processor and high-end storage. While Hadoop just needs a commodity hardware, it almost costs us around $250 per TB. It's an average, and that too with millions of transactions and immense storage space. Let's see what kind of limitations are there in version 1.x and how they were removed in Hadoop 2.x. In 1.x, there was no horizontal scalability. That means there was only single name node. But in Hadoop 2.x, there is HDFS federation, and we can have multiple name nodes. 1.x does not support high availability of name node. Of course, it cannot because it has only one name node. That is one server. While in Hadoop 2.x, we have multiple name nodes, so there is no single point of failure. That is, even one master machine fails, there are other machines also. And of course, there are number of machines, then it is highly available. And same reason, since there was only one machine, so highly overburdened job tracker, only a single job tracker has to handle all kinds of operation. While here, task of job tracker has been divided into two parts: resource manager as well as application master. Here, resource manager manages all kinds of resources, storage, memory, computations. Application master manages resources for an application. In 1.x, only MapReduce applications can run. While in Yarn, as told above also, it supports all non-MapReduce applications also, such as Giraffe, Spark, MPI. In 1.x, there was no support for multi-tenancy. One task tracker can handle only one process. While in Hadoop 2.x, the task tracker can handle multiple processes according to its scheduler, according to its capacity. Now let's see a small comparison between MapReduce version 1, that is Hadoop 1.x, and Yarn, that is MapReduce version 2 in Hadoop 2.x. MapReduce only had one name node, one master server, job tracker, and an individual task tracker for each slave node. While in MapReduce version 2, it has resource manager and application master. Resource manager controls resources for the MapReduce applications, and application master manages resources for non-MapReduce applications. And any system in the world is not perfect, and Hadoop also is not perfect at all. It has too many drawbacks, such as write once read many system. It is not suitable for frequently changing data. I can only grab data and put it there. I cannot change it. Now high latency. Since it works over GBs and PBs of data, I cannot expect it to return into 0.1000 zeros 0.1 second, just like Google does. It is high latency. It's not fit for small data. Due to its high capacity design, if there is small data placed on it, then the control will be spread quite large, and thus efficiency will be lost. It's stability issues because it is open source software and several programmers develop it simultaneously, and any kind of error can generate instability in it. Now, since it works on gigabytes of data and even petabytes, now the multiple data sets which have different type of data types, just like PDF files. Now adding a PDF file into an Excel file or table is not easy task. It's tricky and slow, of course. Moreover, cluster management is hard. If cluster has 100 computers, then you have to deploy human resource to SRS to manage them, troubleshoot every problem of them, and to keep them in sync. And one of the most important drawback, multiple copies of already big data. We create 3 copies of data. That means that if I have 50 GB of data, then 150 GB has been created for it. And to distribute the locality, we produce 6 copies. It means 300 GB of data just from 50 GB of data. A big data which was already big, we made it just bigger. Then inefficient execution, since it doesn't have any query optimization engine like an RDBMS. So the query can take much longer time than they should. Lack of required skills. Of course, we need human resource also to work on Hadoop. Very few people are there who have knowledge of algorithms as well as for distributed MapReduce development. So guys, here we come to conclusion of Hadoop. It is an open source software, distributed processing, large data sets, clusters, commodity servers. So right now Hadoop is a very effective solution for companies dealing with big data. It's an open source and widely used by almost all big companies. With future generations and future modification, we can be sure that Hadoop will be one of the solutions which we have for big data. Thank you guys. Hope you enjoyed it.